Okay, now we're going to talk about specific heat, and in this case, the symbol for heat in thermodynamics is Q, so the change in the heat energy would equal the heat capacity times the change in temperature. That would equal the mass times what we call the specific heat times the change in temperature, whatever units you want. They found this was a function basically of an object, and that was very inconvenient. So they invented the idea of specific heat, which would be the change in the heat energy over the mass over the change in temperature. And like water, for buoyancy and for fluids, they wanted the number to be 1 for water. So they said the specific heat of water is 1 calorie per gram per degree Celsius, or 4,186 joules per kilogram per Kelvin. And you'll find out that water is a very high specific heat. For instance, aluminum has a specific heat of 0.215 calories per gram per degree Celsius. So that means to heat up 1 gram of water would take 5 times more heat energy than it would to heat up 1 gram of aluminum, the same amount. This means as long as the water is in the pot, it's taking all the heat energy, and some heat energy, of course, is going into the pot. Water boils all out. You may destroy your cookware because all the heat then is going into the pot. Happened to me. Okay, so now we understand what we're looking for is we're calculating the specific heat of 5 samples, and we're comparing it to water. So we do what we call conservation of energy. We're in a closed system. And in this case, we're using styrofoam cups because they barely conduct heat at all. You know that if you go to McDonald's and you have a scalding hot cup of coffee and it's in that styrofoam cup, you don't feel it. Go to Starbucks, they give you that cardboard wrap. Oh my gosh, your hand is burning. So in this case, the change in heat energy is going to be equal to 0. The sample is going to come out of the boiling water, and it's going into the water in the cup. So the formula would be this big long thing. It's the mass of the sample, the specific heat of water, times the quantity, the final temperature of the system, minus the temperature of the boiling water. That's a loss. Now the gain is with the water, make it 0. That's the mass of the water, specific heat of the water, times the quantity, the final temperature of the system, minus the temperature of the water in the cup, which should be close to room temperature. So I've got a spreadsheet, and you need to do the math involved in this and calculate the specific heat of those 5 samples.